chat. So I'll send the link. I can't see myself. I'll send the link after the class. Okay, so thank you everybody for joining in, and it's good to have you here this Saturday, first day in February, and the first day of the second month. So why are we here? We just to sort of introduce SQL, and not just introduce SQL, to make sure that you live with projects. So if you're walking along, that's good. Just let me know if you're walking along. That would be nice to see people trying it out. And if you're not walking along, you will also get the recording at the end of the class. Thank you very much. You get the recording at the end of the class. And without further ado, we should start. So Grand Analytics is actually dedicated to helping people skill up and to help them have not just skill up, if you're looking to transition into tech, to help them transition into tech seamlessly and to build future-proof careers. So because we know what the demand is in the industry at the current at the moment, and also because it's things are changing really fast. It was if it took years before, now it's taking literally days, and with the advent of AI and all of that. So things are changing really fast in the industry. And with that, people are losing jobs while some people are gaining jobs. So the goal for Ground Analytics is to help people build future-proof careers, and that we do that by enabling them with skills that we know will transcend the times. We are currently running a Power BI class as well, but today we'll be introducing SQL. So if you're interested, if it's something you've always considered, today may be your make or break decision. But before I go into that, is worthy to note that SQL has been around for a very long time. And personally, I started out with SQL, was it in 2008, I believe. So it has been around for a very long time. Even if there are different variations of SQL, you have SQL with it is basic, it's foundational. It's good for you to know the foundation, then you can easily twist it to suit whatever form you need it in, because we have the MySQL server, we have the PostgreSQL, and we have the what's the third one now? MySQL, PostgreSQL, SQL Server. So, and they have in those three environments, you still use SQL, but it's sometimes it varies. So it's a slight variation. So what may work for one environment may not necessarily work for the other, but it's always a slight tweak. So it's that's the thing about SQL. So once you get the basics right, you are able to build on it. And there's a way to write SQL as well. It has its own syntax. There's a way to write it. It's not, okay, I know all the keywords, and you just jam things together and you're expecting it to work. No, it has a way, there's a syntax for it. And also, SQL is the number one was actually the number one most in-demand sorry, programming language in 2024 for jobs. SQL was like everywhere. And the reason it has gone up that way, it is the fourth most popular. I think Python is the first, Python or Java, one of the two, is the fourth most popular. But for jobs in 2024, SQL was the number one. SQL was the first, and for jobs, people were like, okay, organizations were looking for people that could, code in SQL. I know a lot of people don't see SQL as a programming language. It is still a programming language, because it starts from the basics, from the very simple, and it goes into the advanced SQL. And another thing is, I think the reason why the demand for SQL rose is because some people are just data engineers. Some data engineers, they got the job just by knowing how to write SQL at the advanced level. So it is an MVP for programming languages. And the reason it rose is because of the demand for LLMs, the NLMs, the NLPs, gravitating towards natural languages. So you find environments like Databricks using more of SQL, to perform data engineering and all of that. So it's beginning to infiltrate fields that wouldn't have that were so rigid because before, data engineering was basically Python. You use Python to, write the codes and use it to access wherever. But now, in the Databricks environment, you use SQL. You can use SQL to achieve what you want to achieve with for data engineering. So it's becoming a go-to for programming, and even in for data analysis and all of that. It's for database management. So it is versatile. SQL is versatile. So knowing this one skill and knowing it very well can actually flip things for you. That's that. So that's that for SQL. And again, is also used in the cloud. Used in the cloud. And I think the ability for you to be able to just tweak it to suit different environments, it's just amazing. It's not once you know it at the foundational level and you know it very well, you can you get comfortable when you get into a different environment that requires SQL, even if it's a different variation of SQL. So there are variations of SQL, there are variations of SQLs. So even if it's a different variation, you can still adapt and use it. So it's fun to use, and also depending on the environment that you use again. The one we'll be using today is the SQL Workbench, the interface to access the server, the SQL server. It's the most, with all the environments I've used. I think up until this morning, I was asking myself, why did we have to use the SQL Workbench? With all the environments, I've used some other environments which I've found very beautiful and very inviting. That SQL Workbench is not one of it. But anyway, we'll save that for another time. All right, so I still can't see myself, or I believe the video is capturing me and not half of my head. So let's get to it. I prepared some slides. Okay, so the idea today is to build a database and build a database with tables, and also to build what we call an ERD, so an entity relationship diagram, because building a database it doesn't just end with okay, now we have the tables. Okay, that's it. It's like a whole process. And in building the database, you will see some of the SQL queries that you can write. SQL, by the way, stands for Structured Query Language. Some people say SQL, some people say SQL. Is a language used majorly for relational databases. So relational databases, the word relational has to do with tables. When you think of relation, you think of tables and relationships. In the world of data, you think of tables. Tables that can talk to one another. So SQL is used for relational databases, majorly for relational databases. But we found out that they are beginning to be used even in for databases, that they are being used for databases that are not exactly relational, that are not relational in that sense. Like they don't have structured. I won't say exactly relational. I would say that are not structured. Yeah, unstructured databases. They are being framed in such a way in the cloud to be used for unstructured databases. An example is in the Azure cloud. If you're working in the data lake, you can actually use SQL. You can frame SQL in such a way that you can use it on files in the data lake. So it's the versatility. Yes, it's an English class. It's the versatility of SQL. You can use it in relational environments for structured databases, where you have the tables, everything arranged, everything nice, and for unstructured databases as well, where you have the files and all of that. But that takes a different form because you have to frame it in such a way that SQL can speak between those tables. So yeah, that's them trying to how do you put it? Trying to That's them trying to stretch the use of SQL. So on a final note, SQL could actually be the bridge between where you are now and where you're going, irrespective of where you're going. So if you've just joined us, you can just drop in the chat where you're calling in from, and what's your experience with SQL and why is this important. Yes, that's it. So okay, yes. So I believe if you can see my screen, that would help. So today we are creating a database in MySQL server, and the agenda. What is a database? A database is simple. It's a collection of tables, or a collection of it could be a relational database or a non-relational database. So a database is like a container that holds data. That is the general definition. But in the RDBMS, Relational Database Management System, in for relational databases, what you expect to see are tables. For non-relational databases, you will see things like those ones are even called, the non-relational ones are more prone to be called data lakes, where you can put all sorts of stuff. But for the relational databases, what you will see are tables. So you expect to see tables that contain data. So why do you need a database? I think you need a database. It's like, why do you need a container to hold water? You need somewhere you can go to pick information, store information. You understand? And to store and retrieve information. That's the purpose of a database, to store and to retrieve information. So how do we create a database? That is what we are going to address today. The process of creating a database, and we are also going to do it live. So if you are following me, I know a lot of people just come and, if you're following me live, let me know. So then it's not just me talking. And there's going to be a quiz during this during this class. There will be a quiz, and there's going to be an assignment as well. Please. And then the tools we'll be using today are SQL Server, the MySQL Server, and the MySQL Workbench. So MySQL Workbench, the server is the one that holds all the databases, right? And I dropped a link on the group for everyone to, go to YouTube and, watch the video on how to download and install MySQL Server and the MySQL Workbench, because you need the MySQL Workbench to access the server. The MySQL Workbench is the interface between yourself and the MySQL server. So you actually need it. So it's not only MySQL Workbench that you can use. There's this other one. What's it now? Forgotten the name. There's another one to. In fact, that one is fine and fancy. Yeah. Up to this morning, I was asking myself why I didn't. But it's okay. We'll use the MySQL Workbench. And so the tools are MySQL Workbench and MySQL Server. And we're also going to look at the results. What are we getting from this? So the how. So this is a process that we are going to follow. We would define purpose and requirements. So it's going to be an interactive class as much as possible, but we hope to finish in the next 1 hour. And we define purpose and requirements. And this is actually this is what you follow anywhere you're creating, if you're creating a database. These are the steps. First of all, why do you need the database? What's working with? How will the data be used? So these are the questions that you need to answer when you're talking about the purpose and the requirements. What kind of data are you working with? How will the data be used? And this is going to determine, this will lead to the second one. Okay, yeah, I'm sharing my screen. Let's get off now. Where's my, sorry about that. Yeah. So the first question of the type of data you're working with and how it's going to be used will lead to the second point, which is designing the database. Because when you determine the sort of data you're working with and how it will be used, it will inform the structure of your database, it will inform the tables that you're going to create and the relationships you're going to foster between the tables. So, and Third one, that will then lead to the third one, which is to set up your database environment. And we already have a database environment, the SQL server and the SQL Workbench. Then you create the database. And creating the database is using a set of queries. It's not a honestly, it's not a big deal. We are going to get into that. And then to create the tables. Now, to create the tables, you have to think of your columns, you have to think of the keys and the relationships. Now, when I talk about the columns, we all know that tables are made up of columns and rows. So the columns here are your column names. What is your column going to contain? You know, what is the data type of that column? Then the keys are like the primary keys and the foreign keys. You know, for each column will have its primary key, but it may also contain foreign keys. And these foreign keys are like they are references to the primary keys in other columns. So we'll see how that works also. Then we are going to create the ERD, entity relationship diagram, that is going to show us the relationship between the tables in our database. We must have done all of this before creating the ERD. Is the sixth thing. And the seventh thing is we are going to insert data into the tables to test if our table is actually working or if we've done the right thing. Okay. So as much as possible, this should go smoothly. So, but today we'll be creating a database for a movie streaming platform, Netflix. And before we start, okay, brilliant. Language, yes, yes, yes. Movie genre, movie category, 9 responses, movie title, language, region. Thank you very much. Category, genre, rating, customer ID. That will be part of the customers table, I believe. Cast, that's interesting actually. Region, yeah. This is actually interesting. Thank you everybody uh, for putting this up. You can have a language table, very true. A customers table. You can have the cast, very, very true. Movie genre, yes. Movie category, movie rating, movie title. And yes, thank you so much. The customer ID will most likely be part of the customers table. Or the customer ID, it could even be a table. It could be a separate table, probably um they want the customer ID to have maybe customer name, just details about the customer that can be connected also to the customer's table, probably to create another layer of details for the customer's table. So that's beautiful. Thank you all very much for responding. So movie rating was the highest. I think it gives me an idea of the people that I have in the class. You guys have been rating movies in the past few weeks. You've been rating some movies good and some movies bad. But yeah, thank you very much. So let's go back to our slides. But for today, so we all know Netflix is a streaming platform, right? So, and of course, for other streaming platforms as well, the customer base will most likely be the same thing. Like it's just for streaming platforms when it comes to music and it comes to um, movies, you'll most likely have the same columns or the same tables, just a slight variation. Okay, so streaming database. For today, we're trying to keep it short. So we have the users or the customers. That's one table. We have the movies. We also have the watch history. We have the ratings. So even if you didn't mention anything that's here, trust me, you can have up to 15 tables in Netflix database. So, but these are the ones we'll be working with today, users, customers, then the movies. We'll be working with 4 tables, watch history and ratings. Okay, so customers table, of course, it stores user information. So you can have the customer's ID, you can have the names, your subscription types. Subscription types maybe like premium or normal subscription, something like that, or yearly subscription or monthly subscription. It could be something like that. You have your movies table, you have the movie titles, the genres, the release years, and ratings. Then you also have the watch history table. That's where you track what users watched, what your customers have watched, and when they watched it. You have the ratings table, captures user ratings and reviews for movies. So why do we have it spread it out this way? It goes back to the first point that we made. You have to define the purpose and the requirements. If you do not define the purpose and the requirements of your database, or you don't define what data you're working with, what data you need in your tables, if you don't define that, how do you even design the structure of your database? If you don't define how your data will be used, how do you even design the structure of your database? How do you build the relationship between your database? So that's why we have this. So we can actually build the relationship between these tables. You know, when we have all of this spelled out, you want to know the watch history of your customers. And what does this do when you know the watch history of customers? You can always recommend the streaming platform can recommend based on what the customers have watched. So you can actually detect your customer behavior from this. You can detect the movies that are working well and the ones that are not working well. You can know the why, you can know the what, you can know the how. So it goes beyond having just drawing a database. SQL brings business intelligence to a business. That's what it does. So you think SQL, you think business intelligence. That's how that is the goal of SQL, to draw out intelligence so that they can make informed decisions and to be able to predict for predictions, because nobody wants to run an organization on a loss. And this is why data is important. It is the fuel, it is the oil. Okay. So and when you know the ratings, definitely when you know the ratings, you know what sort of movies, the genre that your customers enjoy. You can actually personalize customer experiences. So that is the reason for, defining purpose and requirements and determining what to do. So here we have defined the purpose, we have defined the requirements, we know the tables that we need. We'll then, in order to derive business intelligence for what we want to do, we have to build a relationship. We have to think of how we are going to build a relationship between our tables. And that is where designing the database comes in. So, okay, I think I put so. So we have to design it. First, you design your database on paper. You don't just go to the SQL environment and start typing things out. First, you design the database on paper. So this is my own paper. And then I have, for my customers table, I have the user ID, I have the username, I have my columns spelled out. I have my columns spelled out so that I can build a relationship between my tables and I can have a database. And the ones I've highlighted in blue, PK basically means primary keys. And these primary keys help to uniquely identify a table. So a primary key is unique. You can never have a duplicate value because a user cannot have two user IDs. And that's why a lot of the time they ask for email address, because your email address is attached to your user ID. They will not ask for, because your email address is unique to you. They can't use your name. A billion people can be bearing your name. So it has to be your email address that is tied to your user ID. So it's a primary key, it's a unique column because each value is unique. The same with the movie ID, each value is unique. That's why it's primary key. It's a primary key column of the movies table. The history ID is the primary key column of the watch history table, and the rating ID is the primary key column of the ratings table. But now I've highlighted things in red. Okay, for the ones I've highlighted in red, these ones are what we call the foreign keys. Why are they called foreign keys? They are called foreign keys because these are the keys that are used to build the relationships. These are the keys that are used to talk to other tables. So because for this watch history table, the user ID is a foreign key, and the user ID can be used to talk to the customers table. So the user ID is a foreign key on the watch history table, but it's a primary key on the customers table. Why is it a foreign key on the watch history table? Because a customer can watch, maybe a customer, because this is watch history table, maybe he has watched like 20 movies or 20 films. 20 films. So his user ID can appear 20 times on this watch history table, but his user ID can only appear once on the customer's table. For the movies, maybe the movies he has watched, the movie with each of his watch history, the movie will be listed. So a particular movie can appear, okay. A particular movie can appear 100 times on the watch history table, but it can only appear once on the movies table. So, and the same thing with the ratings. User ID, a customer can give 100 ratings. So a customer's user ID will appear a lot of times on the ratings table. A movie can be rated 100 times. So it would appear multiple times on the ratings table, but on the movies table, it will only appear once. So are we clear on primary key and foreign key? It's very important for us going forward. So what we've done now is we've defined the purpose and requirements of our database. We because that will inform our database structure, and we've designed the database, what our database will look like. We've done the structure, we've done the columns for the tables, we specified which will be primary key, we specified which will be a foreign key as well. And we've set up the database environment, of course. I've set mine up. I don't know if there's anybody following me. Let me know. And the next thing we are going to do is to create the database. So I think, okay, 1 minute. Okay, no. So the next thing we are going to do is to create our database. So we are going over to our SQL Workbench. So let me come out of here. Okay, so SQL Workbench. Oh, taking a restart. Please, you can unmute.
Okay, thank you very much
You're welcome.
for the presentation. I just wanted to be clear with the foreign key. I think I missed that. Can you just briefly the foreign key?
Okay. Okay. For the foreign key,
Yeah,
Caroline, I saw your message. I will attend to it in a bit. For the foreign keys, the foreign keys are like okay, let me go back to the slides. Um, yeah. So for the foreign keys, the ones in red are the foreign keys. Now, the primary keys are the unique identifiers for the table. It's a column that uniquely identifies each row on the table. So the primary key cannot be duplicated. Like for each user on Netflix, you have a user ID. For each customer on Netflix, you have a user ID that is unique to you. That is how Netflix identifies you. But you as a customer, you can watch 100 movies, right? So the fact
yeah.
that you can watch 100 movies, or you've already watched 100 movies in 2024, and the watch history table has recorded that you watched 100 movies in 2024, because the watch history table would also need to specify the person that watched the 100 movies. That is why the user ID is here. But with each movie, say you watched 100 movies, right? Your user ID will appear 100 times. It is not unique. It is duplicated. It is replicated. It is
Yeah,
everywhere. You understand? It's not
yeah, yeah.
unique. So that's what makes it a foreign key. It's called
Okay,
foreign or multiple keys because a particular key appears more than once in a table.
okay,
That's why
thank
it's
you.
called foreign key. Yeah, you're welcome.
Understood.
Okay, I think I need to answer, then we'll go over to our workbench. Yeah, then we'll go over to our workbench. Let me see. Okay, okay, Caroline, okay, I have tried to follow the instruction on that, but I'm stuck at a pop-up message that requires Visual C++ 2019 redistricted package to be installed. Oh, really? Mm. Please, can we, I would sort this out after the class. Is that okay, Caroline? Is that okay?
Yes, that's okay. Thank you. You
You're
can go
welcome.
on.
So just copy and paste it on the group. I think anybody can write on the
Okay.
group. So you can copy it and paste it on the group so that I don't forget. I would see it after the class. Okay, so let's go on. We are in our SQL environment. I know I've already expressed that this is not the prettiest I've seen. This is, in fact, but we are going to work with it. We are going to work with it. So if you've downloaded and installed it, you must have seen this interface. It's okay if you don't know what to do with it, but this is what it looks like. And we have all these buttons here that tells you what to do and what not to do. well, not what not to do, but what to do. So you have this that you can use this one up here that you can use to create create and execute your queries. Because if I click on this now, it opens a query language and query notepad here, and this is where you see whatever you do, whatever action is taken, it comes up here. Okay, and also okay, that's if I want to create a new schema to be connected to the database. So all of this is what's going through just to study the environment to see how it really works. And then you have your open a SQL script file in a new query tab. Maybe you want to have all your queries in one place. You have different files, you want to arrange them. That's what it's for. So database server tools. So the first thing we are going to do is create our database, right? And SQL file 3. Okay. I've done a couple of work in this environment, so it's giving file distribution at the moment. Okay, so we are moving on to the fourth thing to create a database. I have a little quiz after now, okay? So please, I hope you are noting the steps. I hope you're noting the steps. So to create the database, first of all, what name do we give to this database? What name do you suggest? Please, all names are allowed except Netflix. I don't want to be carried by Netflix. What name do you suggest? It's enough that I've used their logo. Can we get a name for this database, please? Can we get a name in the comments for this database? It would be nice to have a name for this database. Where are you guys? Okay. Movie box. Ah, I like that. Okay, we'll go with the first name, movie box. Fastest fingers, movie box. So we are going to create a database called movie box. Where is my, yes. So to create a database, this is what makes SQL very interesting. Okay. I'm actually getting excited wanting to type the code to create a database. It's just simple, create database. The syntax is create database and database underscore name. I think that was why I brought notes because I know that I knew I was going to, I would want to write stuff. So create database underscore name, meaning the name of your database. And it's good practice to always terminate your queries with a semicolon in SQL. So I'm just going to create my database now. You know what? And it has autofill, so it can the keywords in another environment. Okay, it's movie box, right? Should I do it all small? Let me do it small so that I don't have to create database movie box. And I'm going to execute here. So our database movie box has been created. So I'm going to show database. Let me do show database so we can see that it has been show databases rather. And execute that. So in all of these are the databases that I have in this server. At the back of the server, these are the databases that are in this server, okay? And this is the one we just created, movie box. That's the one we just created, okay? So I'll cancel that. I just wanted to see the database. So now that we've created oh my word. Okay, that's fine. It doesn't, let me just put it back there so that if you're watching it back, you don't start looking for it. Okay, so we have created our database now, which is the step here. Where is that? Okay, design the database. So we've created the database, which is the fourth step. So now we want to start creating the tables. This is the fun part, and I'm going to need all hands on deck. So we are going to start creating the tables. I've already, we've already drawn the design of what our tables should look like. So we are going to start creating the tables. And for our customers table, we have the user ID, we have the username, because our customer should have a username, subscription type, and we have the join date, like what date did our customer join the firm or join the streaming platform, basically. So we are coming back to our SQL here, and we want to start creating the tables. I need to comment that out. Let me see. Create tables. Oh no, this is a keyword. It's a keyword if it's doing that. Okay, if it's highlighted in blue, it's a keyword. So should have yeah, it's still bringing it out, so it's a keyword. Okay. So to create the tables, we are going to use almost the same syntax like we used uh, our our database. And to create tables, you have it as create table, not tables, please. Create table underscore name, meaning your table name. So you're back here and create table. Oh, I don't want to use capital letter. Once you start typing all of this, it brings out the suggestions for you. It's table underscore name. Our first table is customers, right? So let me just stick with them I don't want to use any capital letters. So create table customers. And now, so when you come to create to the creation of tables is a bit different because your table contains columns and you cannot create an empty table. So right, if I run this syntax like this, it will create it, but it will be an empty table. So you cannot create an empty table. So what we are going to do now is we are going to put the columns that we've already identified. We are going to put those columns into our table. Now, the syntax for creating a table is when you've done this, where is that? When you've done this create table, table name, what you need to do now is you have to list the column name. This is the column name. You have to list the data type. And then you have to let us know if it's a primary key or a foreign key. The last one is optional. You only need to specify it if it's if it's a primary key or a foreign key. You only need to specify. Okay. And primary key or foreign key, you write it out in full. So this is the syntax for table. So that's why I said syntax is important. You must understand the syntax for you to be able to fill it in. It makes your work a lot easier. So the first table we are creating is customers, and I've opened that. So also it's good practice to close when you open, just close brackets. Okay, let me take this back. Then do that. Close it. Still going to give me error because there's nothing. It's expecting that I put something inside. So the name of the first column is user ID, I believe. Let's come here to user ID. Okay, so our first column is user ID, and it's the primary key of the column. Then we have the username, we have the subscription type, and we have the join date. So I'm just going to type all of that in a breath and pretend like I remember everything I've just said. So the first thing is user ID, and it's going to be the data type for the user ID will be integer. So I'm going to use int. That's the keyword int. That's okay. And it's also going to be the primary key of the column. So I'm going to type in primary key, primary and key. So you can see the red has gone off because it was expecting an input between the opened and the closed brackets. So that's the first column. The second column is username. Username is a variable character. Now, a variable character it allows text. It allows variable characters allow text. They allow symbols. It just shows that for variable character, it allows you to put in a range of things. Okay, because people's names come in different languages, basically. So the variable character allows you to put in text and a couple of other things into it. So for the name, I'm going to use Vaka, and Vaka has a size. So you must specify the size. You can do Vaka 50, you can do Vaka 200, you can do Vaka 100. What the size just means is it's the space it will occupy in memory. Okay, so I'll just do 100 for this. How do you know what to allocate? If it's the wrong allocation, it will try an error and let you know. Okay. Subscription type. I remember we said subscription type. Subscript. Is that how to spell it? No. Subscription type. And that's this. And the subscription type would also be VACA. Yes. And VACA, and that could be 50 because it is either going to be premium or something like that. And the last thing is join date. Join date, and join date would be date. Date, and that's it. Okay, so this is our first table. This is our first table. So I'm going to run this first table. Okay, before we do that, sorry, I've only created a database. I did not specify the database to be used because I have like 6 databases. So right now it doesn't know what database I want to use to put I want to use for my table. I want to store my table in. Remember when I did the show databases, I had like 5 or 6. There were like 5 or 6 databases in the server on the server. So I need to specify. You have to specify the database to be used. So, and I'm going to put down the step here, and I'm going to use the keyword use, and it's going to use, I've said I will not write this in capital letters. Use database, and I'm going to specify the name of my database, and the name of my database is, okay, no, no, it has said it. Use, I don't need to specify the database. I just need to write the name of the database, and that will be movie box. So it already knows that. So that's correct. If I put database, it would have flagged it. I just remembered I don't need to put database because the use keyword actually, you see that the use keyword knows that it's the database is used for the databases. So it knows, it expects that. So use database. Oh, okay. Create database movie box. Okay. Because it's already in it. I didn't highlight it. So let me highlight this and just do that. Okay, yeah, so use movie box. So now we can use it and I can highlight this and let me put my, okay. I don't need to terminate it yet, but it's good practice. Let's terminate it because it's a different query. So create table and I'm going to do that. And yes, if you look down here, the result of what we've just done, we have created our tables and then we have all of this. So we can also see what our table looks like. And with that, we can do describe table. Describe. Okay, so it brings it out. Describe table and the table name. It will tell us if it's wrong. So you shouldn't be, the goal is don't be scared of experimenting. Describe table customers. And I'm going to run that here as well. And look at that. So I have this, my ID one, select type, simple. It's just come up with the table name is customers, but what I expect to see is I expect to see my columns, or maybe, okay, I will see it in the entity relationship diagram anyway, or when we enter wait till we enter some data into it. So once we enter some data into it, we should see, actually let me try to insert some data into it. Insert into, oh, I don't want to use capital letters. Insert into customers. So I'm trying to insert into the table values. User ID is integer. I'll do 1. Username, because that is a string that should come with let me do Stella. I'll use my name. It's a string. So a string should come in double quotes. Subscription type, let's do premium. Subscription type premium. What else? Then we should have the join date. The join date will be, let me see, because it's date type. Should it be year before? Okay, admit 2010, 02. I'm just coming up with a date, hopefully. It's so that's the date. Okay. This has special characters, so it should it should be in quotes. Okay, let's run this and see. Let's try this table first of all and see. So one row affected is entered that into, it says here one row affected. So let me do a select all from, okay, I didn't terminate this. Let me do a select all from customers. And let's see that. Let's run that and see. Okay, so we can see the columns now. So we did not enter, because there was no data in it, it didn't show us the columns. But we can see the columns now. So for the customers table, we can see the user ID, the username, subscription type, and the join date. And I have my user ID as one, username Stella, premium, and I joined in maybe 5th of February or 2nd of May. It's one of the two. But this is just to show you that that table we've just created works. So yeah, that's to show the existence of the table. Okay, so now that we've proved the existence of that table, let's go on to create the other tables. So the next table will be, let's go to our next table. So from now we'll move rapidly. The next table is the movie ID, title, genre, release year, rating, movies table. Movie ID, title, genre, release year, rating. So it's still the same syntax, create table, and you have the movies. Then you have that open, and you have the closed. Always good practice to open and close it. And then we have this indented. And the first thing is movies ID. Let me catch that back. Movie ID, title, genre, release year, rating. So let's go back. Movie ID, title, genre, release year, and rating. Okay, I think we have that all set up now. Movie ID, title, genre, release year, rating. Movie ID, title, genre. Okay, so we can start putting the types in here. Movie ID will be int, and this is the primary key of the column. Why? Because it uniquely identifies each one. Title will be VACA because a title can be written in Chinese, and so with VACA we would have like let's put 50. Genre, it's also going to be in text and it will be VACA because it can be written in Chinese or written in Spanish with special characters. The idea is anything that has a special character, that has special characters, you should put them in in VACA. They should be of VACA data type. So release year will be dates. Yes, release year will be dates. Then we have the last one being the rating, and our rating will be float. Float because it's a decimal. Float is a decimal. Now, do we have any primary key in this column? No. Okay, so we've created the movies table. So the next table is, I will execute it together. The next table is create table, and we have, I think that will be watch history. Watch history. Table name. Let me scroll down. Watch history. Open the brackets. Always remember to close the brackets when you open the brackets, and then indent it. It's just using tab. It makes your code neater. So watch history. For watch history, we have history ID, user ID, movie ID, watch date. History ID, user ID, what is it now? History ID, user ID, movie ID, and watch date. So we have movie ID, and then we have watch dates. So I'm going to split all of this up. History ID is int, of course, and it's the primary key of this column. So primary key. And then we have the user ID. User ID is int as well. But user ID, as we all know, we'll come to that in a bit. Movie ID is a hint as well. And then we have the watch date, and watch date is the date here. Now, so what are we going to, because the thing is, if I click on this, if I create this table, it's actually going to cause what I would like to call ambiguity. The reason is because the movie ID is the primary key column of the movies table. So it being the primary key column of the movies table, I mean, we can't have a second movie ID in the watch history. But the movie ID in the watch history is here because we are going to use it to build a relationship between the movies table and the watch history table. In the same way, the user ID is the primary key column of the cost of the what's it now? Of the customers table. That's which is here, of the customers table. And we are going to use it to create a relationship between the watch history and between the watch history table and the customers table. So what do we do with this here? Because if we do this right now, it's going to cause ambiguity. So the next thing we are going to do is we are going to specify that user ID is a foreign key in this table. Okay, and the way we do that is very simple. This is why I say that SQL is very, very, very interesting. So foreign key is simple, and this foreign key will just come here and we put the user ID. So it knows straight away that this is a foreign key. But it's not enough to just do that. You have to tell this table where to find this foreign key. And that is where we use references. Remember if you're writing projects and you use references, remember what you use references for. You know, it's somebody else's work, basically. A reference is somebody else's work that you're giving credit to. So it's a way of saying watch history table. Who are you giving the credit for user ID to? So it's going to tell you, okay, you have to tell it, give the credit for user ID to customers table. So I'm just going to specify customers here. I hope that's correct. Customers here, and I'm going to tell it the column, and the column is user ID. Let me go up to see if I spelled that right. Yes, customers. And the column is user ID. So I'm going to close this up. User ID, I'm going to close up the space. So foreign key, user ID on the watch history table is referencing the user ID on the foreign, it's referencing the user ID on the customers table. That's what it means. So it's basically saying that this last statement here just means that user ID is a foreign key on watch history table, but it is the primary key of the customers table. That's what it means. So we are going to do the same thing. So what is movie ID going to be? My people, for those that are in the class, what is movie ID going to be? Somebody can unmute and let us know what movie ID will be to watch history. How do we frame movie ID?
Movie ID, INT, primary key.
Yes, foreign key, movie ID, yes. Where is it referencing?
Movie ID is referencing the the movie table?
Movies table. Thank you very much. Yes. Thank you very much. Oh, sorry. So it's referencing the movies table because the movies table is the primary key of the movies table. So foreign key, and that would be movie ID. And just in case, this can actually carry another name on this table. It can actually carry another name on this table. So not necessarily the same name, but if it's the same content you want to, it's just good practice to let it carry the same name so that you can have there's no ambiguity. So it's referencing movies, and that will be movie ID. Okay, yes, I'm supposed to put a comma here. Yeah, so when you see any red dot or you see it doing some funny stuff here, just know that something is wrong. That's why it's doing that. So this code looks all right. So we are going to do the last table, and the last table is the last table is let's create the last table and create table, and the last table is ratings. Yes. So for ratings, we have oh, this is a lot. We have the ratings table, rating ID, user ID. Okay, rating score, review text, rating date. Create table, ratings table, ratings. I'm just going to leave it as ratings. Open and close. Whatever you open, make sure you close. That's a law in programming. Whatever you open, make sure you close it. Create table, ratings. Ratings ID. Ratings ID. And I saw user ID. There is movie ID. There is let me see again. Movie ID. Then we have rating score, review text, rating dates. Rating score, review text, rating dates. Rating score, review text, and we have rating date. Okay, yes. So we can start putting our stuff in here. Int, and this is the primary key. Oh, okay. Sorry. Primary key. And then we have the user ID, and user ID is also int. We have the movie ID. Movie ID. Oh, no. Movie ID is also int. So we put int in here. And then we have the rating score. Rating score is float. Anything that is decimal is float. So you don't have a decimal in SQL. What you have is float. Float simply means it's a decimal number because your ratings can be 4.5 or 4.9. So it is float. It is not integer. Integers are all numbers, okay? And review text. Review text. What is review text going to be? What is review text going to be? Somebody, anybody? Do I have to come and call names? Maybe. What is review text going to be? We do have two references under watch history. Yes, we have two references under watch history because it's referencing two different tables. Do we have, where does review text belong? Where does review text belong? What is the data type for review text? At least that's why I know that we've been listening. What's the data type for review text? Written date is date. I'm waiting. What is the data type for review text? Where's everybody in this class? Let's see. Everybody is muted in a way that is so quiet and so strange.
It should be char.
VACA, yes, please. Thank you. VACA, thank you very much. Thank you. So it is VACA, and because it is a review text, we envisage that it's going to have, okay, I said I wasn't going to write this in caps, so it's not, though SQL is not case sensitive. Okay, so we envisage that this will be longer, so I'll just apportion it to 255 because review text, people can write a whole lot of things in the review text. So rating date, for rating date, we have this. Okay, create is not a valid. Okay, I know why it's saying that because I did not terminate this. Yes, so that's green, that's blue. So rating date. So the next thing is user ID and movie ID. They are foreign keys on this table. So we have to establish that they are foreign keys. We have to establish that they are foreign keys. So what we're going to do is foreign key. I could just copy it actually and just change it. Oh, just copy it and just change it. Don't try this at all. Don't try this at all. Type it out, actually type it out. So the foreign key here is user ID and it references customer's user ID. And the foreign key here is movie ID and it references the movie ID. So it's actually correct, to be honest. Then I'm going to terminate it here because it's a separate query. So we've actually created all three tables and I'm going to run it. I'm going to run all three. Brace yourself if there's going to be a query. I am sorry, something because I've already created this table, so I don't want to recreate it a second time. And okay, so good news. That was fast. Let me scale this up a bit so we can see. Oh, so we can see now. We've created the movies table here. We've created the watch history table and we've created the table ratings. So if we were to enter data into each one of them, you will find the structure of each of the tables. So describe table customers, let me say describe table movies. I know what it's going to bring out, but I'll give it a shot and see if describe table movies, and let me just play that. Okay, yes, like it did before. So it expects me to put in some values. So okay, let's put in some values in the movies table. Copy. We have to follow the data type and put in some values. Let's just test what our table looks like before we go to the ARD diagram. So for the movies table, movie ID, title, genre, release year, and rating. So movie ID, let's call movie ID 1. What movies? What movies? Let me put Frozen. I'm sorry. I'll put Frozen. So for the movies table, movie ID, then the genre. Let me cancel this so we can see better. The genre, what genre is it going to be? Let me put kids and then release year 2020, rating 5.5. Genre, kids, release year 2020, and rating I'm just going to put 4.5. Yeah. So let's see if this goes through. I want to insert that into the table here. If it doesn't go through, I know what the error would be. Okay, it doesn't match. So there's an error here, it doesn't match. Why is there an error? There's an error because there's a special character here. So let's try it now. Okay, error code couldn't match value count at row 1. Okay, so it needs to tell us which of the, oh, I didn't change it to movies. I put customers. I should have changed it to movies. So sorry about that. Insert into movies table. Let me actually get some space up so that we can see it. I didn't change the name. Error code release year at row 1, 2020, incorrect date value. Okay, because I put date, so I have to put start. So actually, knowing how to also read errors is another skill that you want to look at. You have to know how to understand the errors. Okay, so one row affected, and we have that, one row affected. So I'm just going to do a select all from movies to see. So this is to say that there's no how. Sometimes you will have errors, but you must know how to interpret your errors. You must know how to, so movies, and that will be it. So this is it. Movie ID 1, Frozen, and we have that, and we have that. So our tables are ready. We've created the tables. Remember, it's a database. So let's go on to, where are we? So we need to create the entity relationship diagram. So to create the entity relationship diagram, since we already have all 4 tables in our, we already have all 4 tables And yes, I will also be sending us the script. So we already have all 4 tables. So what we need to do now is to create our database, our entity relationship diagram, which is like the second to the last bit of what we need to do. So in order to create that, and that shows us the entity relationship diagram actually shows us the relationship between the primary keys and the foreign keys. So we come here, database, and reverse engineer. And so this is the interface that it gives you. This is the interface it gives you, and you have your stored connection, TCP, all of these things. And what we do now is we click on next. So you have to put in your password. This password is the password that you put in when you created your database. Okay, I think I entered the wrong password, so I have to go back and enter the right password. Next. Okay. Okay, yeah. So it's connected to database, all of them, all of that. So the next thing is next. And now I have to select the schemas that I want to include. So I want to include just my movie box. This movie box, this is the schema. When it talks about schemas, it's talking about databases. So the database that we created was movie box, and I'm going to click on next, and I have to retrieve. So it has retrieved everything from the movie box. Now these objects are the tables. So you can see it's carrying different names now, tables. And so I have 4 total objects, 4 selected. All the tables that we created are here. And here it says place imported objects on a diagram. Absolutely. So let me show filter first. See. So this filter actually is, if I don't want any table to be included in my diagram, I'll just move it here. I'll just do this. So it excludes, okay, this is excluding everybody, but I can just click on the table and just move it here. That means that it will create my diagram excluding the movies table. So that is what this is for. So I'll take it back. I want everything in, and I'm going to click on execute. And yes, so I'm going to look at the results next. 4 tables from schema movie box, yes, meaning you can also have connect tables from different databases. So finish, and this is it. So here we can see the relationship between our tables, nice, clean, and clear. You have the ratings table connecting to the movies table with the movie ID. You have this watch history connecting to this movies with the movie ID, and you have the customers, connecting to this on user ID. So this is just the beginning, basically, of SQL when you've created this diagram. So this is the beginning of drawing out intelligence. You can draw out intelligence so long these tables are connected the way they are connected. You can actually filter out values from this table. So I can decide customer with user ID 1, how many movies have they seen in this year? And that information is not in the customers table. That information is in the movies table. So I can actually write a query that connects the customers and the movies table and draws information from the movies table for a particular customer. So that is business intelligence. You can study the customer behavior. You can study the type of movies that they watch. You can bring up a whole lot of things. You can know what movie does well in what particular part of the year. So, and this is just 4 tables. Sometimes you can have up to 10, 15 tables. I can imagine that the hierarchy diagram for Netflix, the actual hierarchy diagram will be like 20 tables, if not more, because they will have languages, they will have, the things that you guys mentioned, aside from what we've just seen. So they will have all of those other things besides all of this. So this is what our ERD diagram looks like. It shows it's called an entity relationship diagram because it shows you the relationship between entities. Each of these tables are called entities. I know they're also called objects. It's a lot to take in, but they are called different things in different environments. Okay. So so this is just the beginning. And SQL is very interesting. There's a way to write SQL. There's a syntax for SQL. There's a way to interpret errors. And there's a way to draw intelligence from SQL. And SQL is not just, because this is an on-site database. This is not a cloud database. You also use SQL in the cloud. You can connect a cloud database to an on-site database and use SQL to, to speak to both of them. So it's and you can use SQL to integrate data. So it's a must-have skill. So this is just the basics, but there is more to this. And this is what I would call elementary SQL. There's the advanced SQL. So we all know that in 2025, if you know that you have a skill, you must know that skill like the back of your hand, basically. So how about how to use ChatGPT for SQL? How about how to use ChatGPT at all, even for database management or data analysis? So it's okay, we've created the entity relationship diagram. So we just go through the steps that we've done today, the how, we define the purpose and requirements, we design the database, we set up the database environment, we created the database, we created the tables, we created the ERD, we even inserted data into the tables, even before every other thing. But, this can come anytime. So basically, for us to, if you think that SQL is going to, the truth is SQL can actually move you from where you are now to where you are going. Some data engineers, the only mastery they have, they know all other languages, but the mastery that they have is SQL. They've mastered it to the core. And that is what they're using in their environments. That's what they're using for work. Mastered it to the core. So I believe that 2025 is a year that when you know something, you know it like the back of your hand. So that's why we are also, in Grande Analytics, we are here to help you with that journey. And we are looking at a 6 to 8 weeks course in SQL, and it's going to run from the second Saturday, next week Saturday, for the next 6 to 8 weeks. And what we will be doing, sorry, we'll be looking at the data analysis part of SQL and the database aspect, database administration of SQL, database management, database administration, data analysis, and this can help you to go on to careers like data analysis, operation analyst, whatever it is you're doing now. SQL can actually add a layer to it. And with the creation of new data centers, there will never be a shortage for it. SQL is one skill that there won't be a shortage of, because for it to have gone up in 2024, you can imagine what it's going to be in 2025. And even if they are saying, oh, we do not, I actually believe that the news is going around that you don't need to know how to code. I believe they are trying to streamline the coding to discourage people so that those that are already in coding will master it to the core, and they will be the ones with all the jobs. You understand what I mean? So there's still time for you. The best time to learn SQL was yesterday. The next best time is now. So this is our offer. If you're looking at the SQL language, also, we'll be looking at how to use it in environments, in business intelligence environments like Power BI and Tableau. So if you are looking at SQL, it's going to be SQL in the cloud, SQL in different environments, SQL for database administration, SQL for data analysis. And for the class, for the general class, it's $499. That's the value, but it's $249. But if you register within the next 72 hours, you get 20% off. And then there's installment payment plan. So it's just we've not come to crash the bank, but obviously it's for people to be able to build future-proof careers and not break the bank while doing so. So if you agree with me, this is almost like a token. The truth is you can go and learn it on YouTube. That people will say, oh, learn it on. You can learn it on YouTube. You can learn it on Udemy. It's good, you can do that, but there's nothing like having a structured learning and having somebody guide you through the process and having somebody tell you, okay, this is what works, this is what doesn't work. So you can go on YouTube and learn everything and do what you need to do and all of that, but does it save your time and does it help your focus? So that's and yes, I promised us an assignment. So the assignment is you have to create a database for an e-commerce store. And you have to draw the entity relationship diagram. If you're able to do that, you get 25% off. And yes, with proof. So this is how we intend to help people this period. So do we have Okay, that's okay, Mr. Kennedy. Do we have any questions at the moment relating to the course, relating to anything? Or maybe you have you're already in a career and you want to know how SQL can enhance such, you can also ask. So we are
Yeah.
open to questions.